Welcome to section 3 of the 4-part quiz questions for Competency 13. Number 10. The radius of a circle is 15 units. If the area of a sector is 100 pi square units, what is the measure of the central angle? Okay, so from this sector, okay, we can set all this up in the proportion that we had before, okay? So we have a sector, okay, we say that's pi, and they're giving us the radius, so we say 15 squared, and then we know that that's all over. Actually, we can put it, yeah, we can leave it in degrees, because we can say 360 degrees. And then what we're looking for is the central angle of theta, okay? And yes, we can cancel here. We can cancel pi if you want to. I wouldn't cancel too much more just because it's too easy to make a mistake and not realize it. And also, what do we have here? When they say, if you didn't watch our other videos and you don't remember, they said sector here. The minute that they said that, you know that you have your central on the right-hand side. The proportion is the central angle over the entire, degree of a circle, your one rotation, okay? Which in some cases could also be 2 pi, but we're not going to use that for this situation because I don't think it's necessary because over here our ABCD options are in degrees. So we're going to leave it like it is. Okay, and also, they gave us the radius because they didn't want us to make the mistake, which would be a huge mistake if you said the radius was 10, okay? Because this is a sector, okay? And it is area. So we're using area over area. And this is why I said 15 squared pi instead of the circumference, okay? That all being said, let's move on, okay? So what do we really have? We have 15 squared theta equals 100 times the 360. Divide the both sides by 15 squared, okay? And of course, we have some canceling here. And this will give us the central angle. Okay, let's put this in the calculator. Right? We don't have to worry about order of operations because we're all in the quote unquote same level of operation. Okay. All right. So we have 100 times 360. Now we divide by 15 squared. All right. 160 degrees. And that is correct. Okay. All right. Let's go to number 11. Okay. The central angle of a sector of a circle is 130 degrees if the associated arc, that's important, we're going with arcs, arc length is 2.6 pi feet. What is the area of the sector in square feet? Okay. Because they're giving us an arc length and then they're asking us about area, that's a 2-step. So we have to go through 2 steps. So first, we need to find the circumference. So we gain the radius, and then from the radius, we can quickly find the area. So we have 2 parts going on here. So first, let's find the circumference. So we have our arc length. That's 2.6 pi over C, I don't know C, equals the 130 over the 360. Now we can cancel out these zeros, but that's all the canceling you can do in this situation. It's not as neat and clean as the other practice problems we had. So what do we have now? We have 13C equals 2.6 pi times the 36. Okay, yeah. All right, so then we divide both sides by the 13. Of course, this will cancel. And we get C. Well, let's go ahead and get that right now. All right. Oh, but we need to put pi out here hanging on. All right, here, let me move over a little bit. Remember, we need R. So we really need to leave this in terms of pi. So what do? I leave pi hanging off to the side. So let me erase that pi. Actually, let me rewrite this so you can see it a little differently. We have 36 times the 2.6. And then you can just leave the pi over here. That is acceptable. All right, so let's put that in the calculator. 36 times 2.6 divided by the 13, 7.2. Okay, but remember, that's circumference. And if you look at your options, you can get rid of B. Now, we need to find 2 times what times pi, because we need that R. Okay, so divide the 7.2 that we have, divide that by 2, and that gives us R. Okay, so that's 3.6. That's our R. 3.6 equals our R. All right, so now let's go get the area. Okay, so that will be 3.6 squared pi. Okay, no, wait a minute. That's a total area. What does it say? What is the area of this sector? Oh boy, well, that's our total area. So let's just put a line over that. We don't know what that is. That's going to be our X, no clue. Okay, and then we have 13 over 36. Remember, we simplified that right here. Go ahead and remember, you use that again. Your central angle over your total rotation, right, in degrees. All right, so what do we have? We have 30. Oops, let's go with something a little different here. 36x equals 13 times 3.6 squared pi, right? Divide all that by 36. Divide all that by 36. This will cancel. So what does x equal? Okay, and we need pi hanging out over here on the end. So let's calculate all those numbers there. Okay, we have 13 times 3.6 squared. And now we divide that by the 36 and we get, oh, nice. That's option A. Great, which I'll just write it in for 4.68. Excellent. All right, let's go to number 12. It says if PK equals 12, okay, that equals 12, all right, and KLP equals 30, what is the area of the segment KL to the nearest hundredths? Okay, this is a terminology that you're not going to see a lot. What they mean is this, they're calling this a segment, which is segment of the circle, which is misleading, okay? Depends on what grade level that you teach. If a student hasn't had certain courses, they're just going to say shaded region. So that's what they mean, the shaded region. I just shaded in, okay? All right. So how do we do this? Well, this is what we're looking for. Our goal is the area of that shaded segment equals the sector sector minus the triangle. Okay. All right. So now we know that sector. All right. That sector area will equal. Okay. Now this is 12. Right. And I need you to recognize what we have going on here. Okay. Right. We have for the area, we can use side, angle, side. Okay. So let's get back to that sector. Okay. I know that you didn't notice, but when we were working with a sector and we put it in a proportion, what we had in the end was, if you look at it carefully, we had for a sector, and you can look up here when we dealt with the sector, we had r squared pi times the angle over 36 central angle. Okay? Now, look back up at what we just did. Remember, we took a 0 out here. Let me highlight it right here. Okay? That is our central angle over the 360. It's just simplified. And then look what we have here that we multiplied it to. That's just the area of a circle, which is exactly what we have right here. And that's what I'm going to use. Okay? Great. So we have the radius, 12 squared, and then we have our pi, and then we multiply that by 30 over 360, and that will give us our sector value. Okay, now we need to deal with, okay, that's going to be our sector area. Right, now we need the area of the triangle. Okay, now we have to use the law of sine, and that's why I pointed out side angle side. That means that we can't apply it because we have an angle in between two sides. So that works perfectly. So what are we going to have? We will have the two sides times each other. Okay. Divide that by 2 and then multiply that by sine of 30 degrees. Okay. All right. So really, what are we going to have? Well, first we need to take the sector and figure out what that is, and then we can subtract. Okay. All right. So we have the sector is 12 squared, carry up. That gives us pi in parentheses, 30 divided by, oops, I forgot a 0 right there. Okay, 360, close that. All right, I'm gonna, since I'm multiplying everything together to get the area of that triangle, I'm gonna just type it in the way I see it, okay? Minus, okay, actually that is 12 squared divided by 2 sine of 30. Okay, push enter, cross your fingers. Okay, with a little rounding, we got it. It worked. Okay, all right. So that will be option B. You may want to stop the video for a second and look at exactly what I did, but everything's precise, and that's what it is. So roughly, we needed to round. Okay, so that really is 1.6991, but you round and everything's good. Okay. All right. Number 13. A regular polygon is inscribed in a circle. Which one of the following must be congruent to the radius of the circle? Okay, so what that tells us is we have opposite. If you look down at number 14, it's inscribed. So it's the other way around. It is inside. So if I do this, and let's say I draw some lines like this, and then I would draw like this. And that would be basically what we have. So this would be the radius of both. That is the radius of the circle as well as the radius of the polygon, no matter what it be. Okay, how many sides it has. So I just went with 6 because it was easiest to draw. Okay, so which one of the following is congruent to the radius? Well, we see this from the image. So it would be the radius of the regular polygon. I'm going to go with A, but let's read the others. The apothem of the polygon. No, that isn't going to work because that would be the green line that I'm drawing. Nope, that's out. The diameter, well, in nowhere is a radius and a diameter. That vocabulary just doesn't even jive. Diameter means all the way across. I don't understand that. Okay, D, the perimeter. And how could that be equal to the radius? Doesn't make sense. Maybe there's some shapes out there where this would be true, but it isn't true with this particular situation. So it has to be A. We've got no other choice. All right, let's go to number 14. Okay. Oh boy, this looks like fun. Now, okay, if the radius of the circle is 8 square roots of 3, what is the area of the hexagon ABCDEF? Okay. All right. So that's the radius of the circle. Well, this is opposite of the situation we just said. So this radius of the circle is also the apothem. So let's pencil that in. So we know we have 8 square roots of 3 there. Okay? Now, once again, this is where knowing the properties of your special triangles is beneficial. So I'll draw it larger and repeat what I had before. Okay. Also, I will tell you why I know this is going to work. First, I see 6 sides. When you have the 6 sides, okay, which is your hexagon, 6 sides, you are dividing 360 by 6. This gives you, I'll redraw this. This gives you 60 degrees for every angle. I don't care if you slice it or dice it. And we have done one of these before. That means that I have a 60-30 situation. Okay, I'm going to go with a little bit darker color. Okay, so this means here for this angle, I have 30 degrees. And for this angle right here, that is my 60 degrees. This means I'm going to redraw it right here. I have 30 and 60 in a great situation. This tells me, because they said you have 8 square roots of 3. I know I have 8 here, and I know that I have 2 times 8 is 16 for that hypotenuse. I know this to be true, okay? So that means I can definitely find the area. It's not a big deal. So what do? I know this entire length right here will be 16 because 2 times 8 is 16. Okay, you may want to stop the video, look at it. You could even look online for properties that line all these situations out. Now, we have talked about this before in other videos. Okay, well, that being said, I have a nice situation. I know that the area of my shape, that hexagon, okay, will be equal to my base times my height divide by 2. Now, that's one equilateral triangle. To get a hexagon, you just have 6 of those put together. So I multiply times 6. Okay. Well, you could do this all by hand. And I bet you guys were like, why did you put a 2 there? I apologize. Now it's correct. Okay. You could do all this by hand. I agree. And come out with all different ways to do this. However, this is what I'm going to do. What I'm going to do is I'm going to here lay this out differently, and we're going to put it all in the calculator. And this is what I want to show you. Just like we did with pi, leave the square root of 3 just hanging out on the end. We can do this because we're multiplying and dividing, okay? And if you know your art of operations, you're like, yeah, sure, why not? Okay, so this means I have 6 times 16 times 8. Okay, yes, I know you see things that can cancel, but let's not do that, okay? Let's just do it in the calculator. So 6 times 16 times 8, all divided by 2. 384, but remember, that's 384 square roots of 3, which is option D. Okay? All right. Now, of course, if you aren't familiar with your special right triangles and their properties in this situation, which you need to get there, if not, like we've done in other videos, there are other ways to use the laws of sine to be successful at this, okay? All right, so let's look at number 15. All right, if Km equals 10, all right, that's this guy right here. Okay, if he equals 10, wait a minute. Which one of the following lists the correct perimeter and area of the entire figure? Well, I saw something right now. This triangle is again an equilateral triangle. So if Km equals 10, then I know this is 10, and I know this is 5, and I know this is 5. Well, that's very convenient. And the first thing that I want to do is I want to look at the area, particularly the area of this semicircle that makes the top of this cone shape, okay? So what is that? That would be 5 squared pi divided by 2, okay? Now, I'm going to leave pi, obviously, because notice pi is hanging out over here, okay? We're looking at area first. We're going to look at the area first, okay? All right. We got pi hanging out. So I want to see which value is associated or multiplied to that pi. Okay, so 5 squared divided by 2, that gives me 12 and a half. Okay, well, I automatically know, here, let's erase this. I automatically know that option B won't work. Okay, and I know option D will not be appropriate. Because if you notice, it says area equals, on all of our options, area equals the amount involving pi plus the amount involving the square root of 3. Well, from the problem we just did, we know that it's associated with the area of the triangle. Absolutely. So, well, we know what that's going to be. That's not tough to figure out. We can apply the exact same principle. Well, the hypotenuse is 2 times 5. And we have 5 here, up here. Okay. This means this height that I just drew down the center, that height will be 5 square roots of 3. I don't care how you do it. You can do it all kinds of ways, but this is what we're going to have. Okay. So that means that we're still, yeah, that definitely proves that we're going to have 12.5 pi plus, well, base times height. 5 times 5 is 25. Then we divide by, okay, 25. Yep. 5 times, yeah, you divide by 2. So it would have to be 5 times 5 is 25 pi. Absolutely. I was just trying to prove it to myself. Now we have to shift to the perimeter. Okay. Well, what is the perimeter going to be? The perimeter has to be 10 plus 10 plus whatever that semicircle is. Well, I already see a problem. Look at option A. They have 30. Well, that means that they took all the sides of the triangle and added them together. And that's just incorrect. So option A is out. Well, let's prove the perimeter to ourselves. How do we get that? Well, that perimeter of your semicircle, that semicircle arc, will be equal to 2 times 5 pi. But we have to divide that by 2 because it's half of a circle. It's not a whole circle. So the semicircle, or that arc, half arc, however you want to say it, will be the 5 pi. So we have just verified our perimeter. Okay. All right. So option C is all that we can use. Okay. All right. This is the last question for this section in the quiz practice. Okay. Don't forget to like us, share us, and subscribe if you haven't. Please join us for the last section, and happy testing.